this computer. Okay. I'm recording now. So let's begin our review here. I'll start off with just a few simple questions. So here's a sequence. What's the next element of this sequence? Somebody tell me. Or you can put it in the chat if you want.
70.
70, very good. Yeah. Is this an arithmetic sequence, a geometric sequence, or neither? Again, you can put your answer in the chat or you can tell me.
Arithmetic.
How do you know it's arithmetic? It is.
It's constantly 10 every time.
Yeah, you're adding by 10 each time. So this is an arithmetic sequence. Good. What about this one? 9, 18, 36, 72. What's the next element here? What's the next element in the sequence? You can just put it in the chat if you want.
144.
144. Very good. Yeah. And is this geometric, arithmetic, or neither? Here you are adding by 10 each time. Yes, Brian, exactly. It's geometric. Here, you're multiplying by 2 each time. Since you're multiplying by a constant each time, you know it's got to be geometric. Good. Here's another one. What's the next element in the sequence? Anyone? $60. Is it 60? I think you're right. Yeah, that seems right to me. Okay, why is it 60? Well, look, from here to here, I added 10. From here to here, I added 11. From here to here, I added 12. So it stands to reason next time I'm going to add 13. Okay, so is this arithmetic, geometric, or neither? Neither. Not either, neither. Neither. It's neither geometric nor arithmetic. In arithmetic sequences, you're adding the same thing every time. Here, I'm always adding 10. In geometric sequences, you're multiplying by the same thing every time. Here, you're not multiplying by the same thing every time. Good. So this is neither. Let me do one more. 1/2, 1/3, 1/4, 1/5. What's the next element in this sequence? Hopefully you can all get this. A 1/6. And so is this arithmetic, geometric, or neither? Dylan says geometric. I don't think it's geometric because look, from here to here, what did you multiply by? Well, I need to get a third on the bottom. So to get rid of this 2, I need to multiply by the top by 2, so the 2's cancel out. So I multiplied by 2/3. And from here to here, I need to get a fourth on the bottom, and I need to get rid of this 3. So I multiply by 3/4. You see how these aren't the same thing? From here to here, I multiply by 4/5. Okay, so these aren't the same thing. I'm not multiplying by the same thing every time. In fact, this is neither arithmetic nor geometric. Okay, this is neither. So that was just a brief review on geometric sequences. Let me, can I go on to the next slide here? Yeah. Do I have any questions? Are there any questions in the chat? No, doesn't look like it. If you want to raise your hand and ask a question, you can do that too. There's a raise hand button on Zoom. Okay, let's graph, and you guys will tell me if you need more questions like this. Graph the following. Graph this guy. Can we graph this? Can somebody tell me what the center here is? Well, first of all, what is it? Is it a hyperbola? Is it an ellipse? Is it a circle? It is an ellipse. Good. So we're graphing an ellipse here, and the center, I hope everybody can tell. Yes, exactly. Andy got it. It's 2, 3. Well, the center is 2, 3. Let's just orient ourselves here. 2, 3. Good. Well, if the center is 2, 3, then my A value, yes, an ellipse is the oval shape. My A value here is 5. So in the horizontal direction, I'm going to go 5 units either side. And if this is 2, 3, and I'm going 5 units to the right, that's going to make this 7, 3. And that's going to make this, let's see, 2 minus 5 is minus 3, 3. All right, good. So these are, doesn't A have to be greater than B? No, not really. No. No, A does not have to be bigger than B. My B value here is 10. Does everybody see how I got 5 and 10? You just take the square roots of these. So this is A squared and this is B squared. So if my B value is 10, that means I go from the center, I go up 10 units, and I'll go down 10 units to get the other, to get, well, in this case, here I got the vertices, sorry, here I got the co-vertices, here I'm getting the vertices. Dylan, maybe it could be that Lumen guy does A always has to be bigger than B, but I don't do it that way. I don't think Lumen guy does it that way either, but anyway. I think this is much easier instead of having to remember, oh, A has to be bigger than B. A is just the one that's under X and B is just the one under Y. All right, good. So if this is 2 comma 3 and I'm going up by 10 units, this is going to be 2 comma 13. Going down by 2 units gets me 2 comma minus 7. All right, and so now I can connect these points up. Andy says that depends on the type of ellipse it is. In this case, A is greater than B, then it's a hot dog shape. When B is greater than A, then it's a corn dog shape. Yeah. Yeah, so because B is greater than A, we're in the corn dog scenario. It should look like a corn dog. But you don't really have to memorize it. I think if you just think it through like this, you'll be fine. If you just get the center and then figure out what the vertices and the co-vertices are, you'll be fine with graphing this. So does anyone want another example like this? I'm happy to do another example.
Yes.
Yes, okay. So I'll give you guys a minute to try to graph this thing. Yeah. So graph this using, the steps that I gave you before. So just graph this. Using the question we did as a reference, graph this. I'll give you about a minute. Oh. I hope nobody actually went to Hunter. I'm sorry, Carlos. You should have checked Blackboard. Well, you're here now, so it doesn't really matter. Was there anyone there? Oh, okay, good. I mean, not good for you, but at least I know that everyone who's not here knows that they should be here. All right, I'll give you another 10 seconds. Okay, so let's start. What is the center?
No. I'm still-
Oh my goodness, okay. All right, I'll give you another 10 seconds. For now, I'll check my email to see if anyone went to class. Okay, let's start. It should take you about a minute, I think. The center is -1, comma 3. Yes, good job, Taiwo. Let's see. -1, comma 3. Good. And my A value here is 6. My B value is 4. All right, A is 6. That means that in the horizontal direction, I'll go 6 units. So this is, let's see, if I'm going 6 units to the right, that means that this is 5, comma 3, and this is -7, comma 3. Hopefully that's clear. And then my blue here, sorry, my P here is 4. So I'll make this height 4. if that's 4, then let's see, this is -1 comma 7, and this is -1 comma -1. And then you can connect these up. Mine doesn't look great, but I'm not really going to be judging how nice your ellipse is. I'm going to be judging how right your points are. Okay, hopefully that's clear. All right, any questions? This would get you full marks on the exam. No questions? Okay. Now, let me just check my notes here. Yeah, so let's do this one. Find the sum of the following find the sum. -3 plus -12 plus -48 plus all the way up to -3072. So you can use your notes to do this one. I'll give you about a minute or two. Try to do this question. I'll give you about a minute. I'll get my calculator ready here. Another 30 seconds on this question. You can raise your hand or make a comment in the chat when you've got it. Has nobody got this one? Okay, let's do this question together. Okay, Brian, let's check your answer. So this is, hopefully you see that this is a geometric sequence. That's the first thing to note. This is a geometric sequence. And the partial sum for a geometric sequence is given by a sub 1 times 1 minus r to the n all over 1 minus r. In that playlist, I do go over an example like this, the playlist that I posted on Blackboard. I do go over an example like this one. So you could, if you're confused about this, you can check that. So, okay, this is the formula for the nth partial sum, but the problem is, I know this is the first term, this is the second term, this is the third term. What term is this? This is the nth term. I don't know what n is. So I have to figure that out. Well, I know that the nth term in a geometric sequence is given by a1 times r to the n minus 1. Hopefully we all remember that. Okay, so this is saying minus 3072 is equal to minus 3 times, what's my r here? I'm multiplying by 4 each time. 4 to the n minus 1. Okay, and so now you just do the calculation. Let's see, 3072 divided by 3. So this is 124 equals 4 to the n minus 1. You could do log base 4 if you wanted to, or you could think out, okay. You could think out, all right, 4, 16, 64. You could just do this on your calculator so many times, right? Next is 256. And then next is 1024. So this is 1, 2, 3, 4, 5. So that means that 5 is equal to n minus 1. And so n is equal to 6. So this is the sixth element in this term, in this sequence, rather. This is the sixth term in this sequence. Okay? All right, and then from there, we can plug everything in. I know S sub n is going to be minus 3 times 1 minus 4 to the 6 all over 1 minus 6, which, let me plug that into my calculator. This is going to take me a minute. 1 minus 4 to the 6 times minus 3 divided by 5. Huh. Hold on a second. I'm getting something silly here. What's wrong here? Did anyone catch a mistake that I made? Let me do this again. So this is minus 3 times, I'm getting the wrong answer. One minus 4 to the 6. What is 4 to the 6? 4096. Oh, it's because I'm doing minus 6 instead of minus 4. That makes sense. That makes sense. This is more correct. Okay. And then, yes. Okay. That makes more sense. Good. I did the R should be 4 here, not 6. I don't know what I was thinking. Anyway. Let me move this here. Oops. I can't delete these now. Goodness, I don't know what to do about this. Just want to move it, but it won't let me. Okay, well, anyway. The answer is negative 4096. Yes, thank you, Maria. Maria, why did you come to class so early?
Wait, are you also doing one for our like class time at 11?
Of course.
Oh, Because I saw on the Zoom meeting, it said that the appointment is at 9:30. So I
I'm just
thought
going to
I
be
was
using the
late.
same, I'm going to be using the same room.
Oh, okay, it's fine. I don't mind joining
Okay.
twice. I'm home anyway, so it's not a big deal.
All right. So why 4 again? Because R is 4. Here I'm multiplying by 4 to get to the next term. Do you see that, Deborah? So my R here is 4. R is the common ratio. We can do another one if you guys want. Let's do find the sum, find this sum. I feel so bad. You were supposed to sleep in today. I'll give you about a minute for this one. Okay, let's do this question together. So I know the nth partial sum for a geometric sequence, this is a geometric sequence, I'm multiplying by 2 each time, is given as follows. It's going to be a1 times 1 minus r to the n all over 1 minus r. I know what a1 is, and I know what r is. They're both 2, starting at 2, and I'm multiplying by 2 each time. But I don't know what n is. I know this is the first term, this is the second term, the third term. What term is this? This is the nth term. Let's try to figure it out. I know that the nth term is a sub n is equal to a1 times r to the n minus 1. So in this case, 2048 is equal to 2 times r is again 2 to the n minus 1. So you can say this is 1024 equals 2 to the n minus 1. And so what is this going to be? You can use your calculator to figure it out, or you could just count by 2. So 2, 4, 8, 16, 32, 64, 128. This is the lame way to do it. 256. 5. What should this be? 512. Yeah. And then 1024. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is telling me that 10 equals n minus 1. So n is equal to 11. So my n here is 11. This is the 11th term in the sequence. So now if I just plug everything in, I get 2 times 1 minus 2 to the 11 all over 1 minus 2, which is 2 times, let's see, 2 to the 1 minus 2 to the 11. Let me do that on my calculator. Even though I'm pretty sure that's 2048, but Yeah. That's 1 minus 2048 all over 1 minus 2 is minus 1. So that's going to be let's see, times 2. Oh, 2047 times 2. So that's going to be 4094. That should be the answer. So this sum, at the end of it, you get 4094. You might think, well, I'll just add them up on my calculator, but then you won't get full marks. You'll get some marks for that, but you won't get full marks. You have to show me which of the which formula you're going to use. It's going to say on the question, explicitly state which formula you're using. I'll want to see this sort of thing and you using this. So does anyone have any questions on how to do this? Okay, let's move on. Find 11 factorial all over 9 factorial. What is this going to be? Does anybody want to do this question? No? Okay, well, if you looked at my videos, just the trick is to expand everything out. So this is what 11 factorial and 9 factorial look like when you expand everything. And now you can just cancel. And so this is just 11 times 10. Oops. Which is 110. Somebody want another example of this? Yes, okay. What about, how about this? 6 factorial all over 3 factorial. What is this going to be? Well, that's just, if you expand it out, 6 factorial is this, 3 factorial is this, and you can just make these cancellations. So at the end, you just left with 6 times 5 times 4, which is 120, I believe, right? No, 5 times 4 is 20, times 6 is 120. Okay. All right, good. What else? What about 7 factorial all over, no. What about 3 factorial all over 0 factorial? What's that going to be? 6, exactly. Because this is 3 times 2 times 1. 0 factorial, we said, was 1. If this was just divided by 0, we wouldn't be able to do it. So this is just, 1 always cancels. So this is 3 times 2 times 1, which is 6. All right. So hopefully that was all right. Now, yeah, how about this? Write out the terms of the sum This will be number 1. And this will be number 2. Oops. Okay, write up the terms of this sum. I'll give you about 1 minute to try this on your own. Okay, so hopefully you were able to do at least one of these. For number 1, if you were to expand this out, you'd get, well, remember how you do this. You start your I at 1, so you just plug in 1. This is 1 over 2 to the 1. Then you increment. So this is now 2, so you plug in 1 over 2 to the 2, and then you increment again, 1 over 2 to the 3rd. And the 3 tells you when to end. So that's that. You could simplify if you wanted to. You don't really have to. And that's that. Okay. And for number 2, you do the same thing, except now you're starting at 7 instead of at 1. So the first term is 3 times 7 plus 6. Then you increment 3 times 8 plus 6 plus 3 times 9 plus 6 plus 3 times 10 plus 6. If you wanted to, you could simplify this. Let's see. This is 21 plus 6, which is 27, plus this will be 33, plus 39, plus 45. Oh, did I get that right? Oh no. Well, I was just guessing. That's wrong. This is 27, 3 times 8 is 24. 24. Oh, so this should be 30. Okay. And this should be 33, I think. And this should be 36. Okay. That's better. Why is my name here? Okay. Was this clear for everyone? Do you guys want another example of this? Does anyone want another example? No, okay. Let's see. Okay. Find the sum. Find the following sum. The sum from I equals to 30 up to 80 of 3i. So I'll give you about a minute to do this question. Or would you rather that we went over it together? Together, okay. So to do this question, well, okay, I'm gonna write out the first two terms of this sequence. This is gonna be 30 plus 33 plus 36 plus all the way up to 80 times 3, which is 240. Okay, so this is what my sequence looks like. This is an arithmetic sequence, and I'm adding by 3 each time. So if I were to write this out, I know that S sub n is equal to A1 plus A2 all over 2 times n. I know what A1 is. Isn't 30 times 3 90? Ah, you're right. I made a mistake. Sorry. I'm a little slow today. 93 plus 96 plus blah, blah, blah. Okay, that's better. I know what my A1 is. I know what my AN is, but I don't know what N is. Sorry, this is AN. What is N? Well, let's see. How will I figure that out? I know that A sub n is A1 plus D times n minus 1. So that means A sub n is equal to 90 plus 3 times n minus 1. So that means that 240 is equal to 90 plus 3 times n minus 1. So let's see. This is 150 equals 3 times n minus 1. 50 equals n minus 1. So that means that n equals to 51. So this is 51. This is my first term. This is my second term. This is my 51st term, 51st term. Okay. So now I know I'm looking for S sub 51, which is going to be 90 plus 240 all over 2 times 51. And if I were to plug that into the calculator, let's see, that's 8,415. That means that this sum is 8,415. Yeah, I can believe that. Yeah, because you're adding 100 about 80 times. Okay. That makes sense. I get this right. I feel like that's okay. Yeah, I think that's right. I didn't make any silly errors. Okay, so now I'll give you a question to do, and find the sum of, let's say, here. This is a good question. No, the call is not frozen. I'm just waiting for everybody to do this question. Okay, but maybe you're finished, so let's go over it. Let's expand this out. It's nice to see what's going on. This is 122 plus let's see, 132 plus 142 all the way up to 402. Okay. And I know that this is an arithmetic sequence, so the nth partial sum is given by a1 plus a sub n all over 2 times n. So that's fine. I know what my a1 is. I know what my an is, but I don't know what n is. So I have to figure that out. I know that the nth term is given by a1 plus d times n minus 1. Plugging in a few values, a1 is 122, d is 10. So this is the nth term here. I'm trying to find n when a sub n is 402. All right. So now I just have to solve for n. Subtracting 122 on both sides, what do I get? The 2's go away, so 40 minus 12 is 28. So this is 280 equals 10 times n minus 1. 28 equals n minus 1. So n is equal to 29. Okay, good. So n is equal to 29. So this is actually a sub 29. Now I'm just going to plug everything in. And let me plug this into the calculator here. $7,598 is the answer, apparently. 7,598. So this big sum here, 7,598. Is everyone okay with that? Yes. Okay. All right. If there are no questions, I'll move on. Okay. Put the sum in sigma notation. Well, plus 15 plus 18 plus all the way up to 312. Well, okay. I need to put this in sigma notation. So I'm summing over, well, first of all, what am I summing over? I know that the nth term here is going to be, well, I'm starting at 12 and then I'm adding 3 n minus 1 times. That's just an arithmetic sequence. So I'm going to be doing 12 plus 3 times n minus 1. You could simplify that. You don't have to. All right, fine. But what are my limits here? N is from what to what? Well, n, I'm starting at 1. And what am I going up to? This is 1, this is 2, this is 3, this is n. So I'd better figure out what n is here. Then that'll be my upper limit. So that's 312 equals 12 plus 3 times n minus 1. So this is 300 equals 3 times n minus 1. 100 equals n minus 1. So n is equal to 101. So starting at 1, ending at 101. Okay. Is everyone okay with this, or should I do another example? Does anyone need another example? Even for just one person, I'll do another example.
Yes.
Okay. What about, so try to do this one. Let me think. 10 plus 17 plus 24 plus all the way up to, I hope this works, 360. I hope that's right. Okay, put this into sigma notation. All right, fine. Let's see. Sigma of, well, what am I summing through? I'm summing through this sequence. What is this sequence? Well, a sub n is equal to 10 plus, and what am I doing? I'm adding 7 each time. So this is what I'm summing through. You can simplify this, but you don't have to. Where am I starting at? I'm starting at 1. And what am I ending at? So this is 1, this is 2, this is 3, this is n. So I'm ending here. But what is n equal to? Let's figure that out. 360 equals 10 plus 7 times n minus 1. So 350 equals 7 times n minus 1. 350 divided by 7. Does that work? What is 350 divided by 7? 50, right? Yeah. So 50 is equal to n minus 1. So n equals to 51. So I'm going up to 51. So a nice compact way of writing this sum would be n equals 1 to 51 of 10 plus 7 times n minus 1.
I have a question.
Go ahead.
Why are you starting it off as n is equal to 1, not n is equal to 10? Because I thought you always make n
Because-
equal like what it's starting off with.
Because this is the first term. This is so think about it like this. This expression gives you the nth term, right? So you can think about it like this. I'm summing through a sub I, where I equals 1 to 51. Right, Maria?
Yeah,
What is a sub I? Well, a sub I is just going to be this thing. So how do I get the ith term? I just plug it into this formula here, right?
Okay, yeah, I understand now. Just that I always thought you make n equal to like the first term, so it'd be like n is equal to 10, but I guess you make n is equal to 1.
Yeah, it's n equal. Think of it not as the number explicitly, but the index of the number. So this is the first term, the second term, the third term. Think about it like that. Okay.
Okay, thank you.
Mhm. All right, and just do a lot of examples like this. The questions that I go over in class, make sure that you do a lot of questions about that topic. Excuse me. Okay, so one more topic, and then I guess I'll be ending pretty early. So let's do the binomial theorem. If you didn't go over the video on the binomial theorem, then this is going to be a pretty tough, then you're not going to understand what I review. So I recommend just go on YouTube and click on my playlist and watch all those videos, that entire lecture actually. It'll prepare you really well. So let's do, let's do, for example, 3x plus 1 to the third power. Or let's actually start off simpler. Let's start off with x plus y to the fourth power. Let's do this question. Let's expand using the binomial theorem. Well, binomial theorem, remember what the binomial theorem says. It says x plus y to the nth power is the sum from k equals 1. Hold on. What does the binomial theorem say? K equals 0 to n of n choose k, x to the n minus k, y to the k. All right. So this is saying that x plus y to the fourth will be equal to the sum from k equals 0 up to 4 of 4 choose k, x to the 4 minus k, y to the k. All right, so this is, I do it really slow and lame, so I just do, okay, so this is 4 choose 0, x to the 4 minus 0, y to the 0, plus 4 choose 1, x to the 4 minus 1, y to the 1, plus 4 choose 2, x to the 4 minus 2, y to the 2, plus 4 choose 3, blah, 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 all the way up to 4 choose 4, x to the 4 minus 4, y to the 4. Okay, so from here, if you watch the videos, you know, now we draw the Pascal's triangle. So let's draw this out up to row 4. If you didn't watch the video, this is going to look like black magic to you. Okay, good. So now I know 4 choose 0 is going to be, I'll go down to the 4th row here, it'll be 1. And I know that 4 choose 1 is going to be 4. And I know that 4 choose 2 is going to be 6. And I know 4 choose 3 is going to be 4. And I know 4 choose 4 is going to be 1 again. So now I'll simplify everything. I know that this is 1 times x to the 4. Y to the 0 is 1, so I'm not going to write that. 4 choose 1, we said was 4, x to the 3rd, y to the 1, plus 6, x squared, y squared, plus 4, x to the 1, y cubed, plus 1 times x to the 4 minus 4 is x to the 0, which is 1. I'm not going to write that. Y to the 4th. So that's the answer. Is everyone okay with that? Again, if you didn't watch my video on the binomial theorem, then this isn't going to make any sense, so you have to go watch that. Somebody want another example? Okay. Let's use the binomial theorem to compute 3x plus y to the 3rd. Let me just make this 2x so I don't mess up on the calculations. Okay, 2x plus y to the 3rd. Well, in general, I know that the binomial theorem tells me that x plus y to the n is the sum from k equals 0 up to n of n choose k, x to the n minus k, y to the k. All right. So what this is saying is now instead of x, you're going to have your x is 2x and your y is y. So this is saying x plus y, sorry, 2x plus y cubed will be the sum from k equals 0 up to 3 of 3 choose k, 2x to the 3 minus k, y to the k. Okay. So if you were to expand this, what would you get? You'd get 3 choose 0, 2x to the 3 minus 0, y to the 0, plus 3 choose 1, 2x to the 3 minus 1, y to the 1, plus 3 choose 2, 2x to the 3 minus 2, y squared, plus 3 choose 3, 2x to the 3 minus 3, y cubed. Okay, so from here, we can draw our Pascal's triangle and go up to row 3. It's the 4th row, but it's row 3. Remember, I say that this is row 0, this is row 1, this is row 2, and this is row 3. Okay. And then from there, you can say, all right, well, 3 choose 0. I know that that's going to be 1. 3 choose 3, 3 choose 1 is 3. 3 choose 2 is 3. And 3 choose 3 is 1. Okay. So this is 1 times 2x to the third is 8x cubed, y to the 0 is just 1, plus 3 times 2x squared is 4x squared, y to the 1, plus 3 choose 2 is 2x to the 1, y squared, plus 1 times 2x to the 3 minus 3 is just the 2x to the 0, which is 1, y cubed. Okay, so you put it all together. This is 8x cubed plus 12x squared, y to the first, plus 6x, y squared, plus y cubed. Okay. So that's the answer. Is everyone okay with that? If I put that on the exam, would you be happy? There's one more question that I'll do. So now, find the third term in 3x plus 2 to the 4th. Find the third term in this guy. Well, we know, remember this was, are we doing anything with distance formula? So I'll answer that in a minute. Find the third term in this guy. Well, we know the r plus 1 term in x plus y to the n is given by r choose n, x to the n minus r, y to the r. So we're trying to find the third term. And so the third term is, you can think about it as the 2 plus 1th term. So my r here is going to be 2. So that means that the term that I'm going to use here, the way I'm going to plug this into the formula is, this is going to be 2 choose 4, x to the, oh, what's my x here? My x is actually 3x, and my y is 2. So this is going to be 3x to the 4 minus 2, y, 2 to the 2. And what is 2 choose 4? Let's figure that out. I'll draw my Pascal's triangle up to row 4. And what is 2 choose 4? Oh, sorry, did I mess this up? Sorry. This should be n choose r, not r choose n. That's better. Okay, so 4 choose 2. Let's see. This is the 4th row. Sorry, this is row 4. And this is 0, this is 1, and this is 2. So 4 choose 2 will actually be 6 times 3x squared is 9x squared times 4. And now if you put everything together, this should be, let's see, 6. So 6 times 4 is 24. 24 times 9 is 2. Oh, wow, that's hard. 6, 12, 24 times 9 is 216. Yeah, x squared. 216x squared. You would just put it into your calculator. I can usually do that, but I'm a little groggy today. Okay. So is this clear how we did this? You just need to know that the r plus 1th term in x plus y to the n is given by this. Are we doing anything with the distance formula? Well, if a question appears in your review concerning distance formula, then it's fair for the exam. I'll put it that way. All right. Are there any questions on this? Does anyone want a different example? Nobody wants a different example. That's basically everything I wanted to go over. So if you have something you want to go over, we can go over that. But otherwise, you can go. So I'm actually going to stop recording this.